what we're going to look at today is how our polynomials graph based on their factor form. We've been looking at polynomials in their standard form, polynomials that look like this, and classifying them based on their leading term. But polynomials can also be represented in their factor form, something like this. These two expressions here are equal. They have the same value. So the factor form of a polynomial is going to look something like this, and it allows us to get a little bit more information about the graph, so we can actually sketch a graph that makes a little bit of sense when we look at it. The first thing we're going to do is classify this. Classifying standard form was really easy. You just look at the leading term. But for classifying from the factor form, we have to look at every term that's an x value and just count them up. How many are there? 1, 2, 3. Since we have 3 x terms here, these are the factors that are going to multiply up to our leading term. Notice how x times x times x is x cubed. So this 3, the number of x terms that we have, that gives us the power of our leading term. And it classifies our polynomial as a third-degree polynomial. The other thing to do when classifying is to understand if it's negative or positive, and that would just based on not this sign here, here, and here, but the sign in front of the x. So this is positive, this term is a positive x term, and this x term is positive as well. And if all of our x terms are positive, then our third-degree polynomial is also positive. We've just classified this. So, we don't need this anymore. We just need the factor form here. And we're going to use this to find out information that's known as the zeros or the solutions of the polynomial. And to do that, we're going to find the values for which this polynomial is 0. And we get to take it piece by piece. We're going to look at each factor to determine when each factor would be 0. For what x coordinate our factor here would be 0. And that's going to be an individual solution to our polynomial. So, if x plus 2 equals 0, then we can solve for x. And find out that x equals negative 2 is a 0 or a solution to our polynomial. I'm going to explain why it's called a 0 when we start to graph it. What happens with x minus 2? If x minus 2 is 0, then we can add 2 to both sides and find out that x equals 2 is another option for a 0 or a solution to this polynomial. And we'll do the same thing with x minus 3. Set it equal to 0, solve for x, and find out that x equals 3 is a 0 or a solution to this polynomial. So this polynomial with 3 factors has 3 zeros, 3 solutions. They are negative 2, positive 2, and positive 3. So these zeros of negative 2, positive 2, and positive 3 are actually the points on the graph where our polynomial crosses the x-axis. These are the x-coordinates of the points on the graph where our polynomial crosses the x-axis. So once we have a graph put up here with just our x-axis, we're sketching this graph. So notice I didn't even bother to mark my y-coordinates. I'm not particularly concerned about them right now. I'm just sketching the graph, and the most important thing about the sketch is where the zeros lie. So, if the zeros are the x-coordinates where the graph intersects the x-axis, we just put points there. We put a point at negative 2 on the x-axis. That's one of our zeros of our polynomial. We're going to put a point where x equals positive 2 on our x-axis. And we're going to put a point where x equals positive 3 on our x-axis. Here's a good understanding of visually why these are called zeros. The values, the y-coordinates at these points are all 0. So that's why they're called zeros. These points of -2, +2, +3 are the zeros of the graph of the polynomial because they have y-coordinates of 0. Now, to finish sketching the graph, we have to recognize the classification. Remember, we found out it was a third-degree polynomial and it was positive. That tells us a few different things. One, it tells us that it's going to either start up or down and then finish the opposite direction. That's the end behavior. The 3 tells us that it has at most 2 turns, right? So it's either going to be up, down, end behavior, or down, up. It's going to have at most 2 turns. And the fact that we've determined it was positive tells us which end behavior we're looking at. Down, up, end behavior. So now we know that it's down, up, end behavior. It's going to have 2 turns, and the graph is going to go through all 3 of these points. There's only one way to sketch that graph. We have to start down, and we're going to go through this point. We're going to do 1 turn before we get to the next point. And we're going to do our second turn as we go through the third point, ending up. So the graph sketches very simply. We figure out our end behavior based on classification and whether it's positive or negative. We also determine how many bumps or turns there are based on classification. And then we use that information and the 3 zeros we found to sketch the graph. We're going to end up something like this when we sketch the graph of a polynomial from its factor form.